Okay, part F says graph the function with the features found. Okay, so I'm gonna go back to the previous part, collect all the features, and then jot them down. And then when I snap my fingers, all the features will be magically there by the power of editing. Okay, so I'm here with all the key features from earlier. First thing I'm going to do is plot x equals 1/2 as a vertical asymptote. This is just something you need to know from DP1 semester 1, okay? Natural log functions always have a vertical asymptote. You can find it by setting the argument equal to 0. So what I'm going to do is just draw a dotted line here, and that dotted line will represent my asymptote. Next thing you have to do is you have to plot your intercept, okay, just to give you a point. Again, you just need to plot it roughly. Like, for example, if e is roughly 3, then e cubed, I know that's a really rough approximation, e cubed is 27, 27 plus 1, 28, divided by 2, 14. So, okay, like, it just needs to be very rough, and it doesn't even need to be, it just needs to be labeled, really. That's the important thing. Okay, so I've plotted that and I've labeled it. Now, here's the thing. What you need to do is, number 1, ignore everything to the left of 1/2. Okay, function has to be increasing. Function also has to be concave down. Okay, so this is what concave down curves look like. And you can see that concave down curves here on this part, it's increasing. This part, it's decreasing. So we want the part of the concave down where it's increasing, okay, because the first derivative is positive. So really, we just want this part of the curve. Okay, so you just draw that part of the curve, and you try and make it so that it passes through this point, okay? And it's not going to be perfect, okay? Mine is actually quite ugly, but hopefully that makes sense, okay? By the way, this is not going to 0. Maybe I should clarify. Like this thing here is going off to infinity, okay? Because the natural log function, even though it grows slowly as x goes to infinity, the natural log of x also goes to infinity, okay? So that's kind of me doing end behavior analysis in my head. Okay, this last question is kind of a difficult question. I was kind of debating whether to even go over it, but I decided to go over it because I think there are important things you can learn from it. What I mean by that, when I say there are important things you can learn from it, is that there's a consistent trend that I've noticed with the grade 12s who are currently graduating. Students who would score like a 6 or a 7, on their final mocks and also on their final externals. These students had like an ability to almost look at constants and separate constants and variables very well in their head, and also reason about unknown constants without too much trouble. It's one of those traits that like I've noticed over the years of teaching Math HL, that the students who typically score in the 6-7 band, they have this ability to deal with unknown constants, even if they're just constants, and even if they don't know their values, they can still reason precisely about the function. And today I want to go over that. It's important for many reasons. And one reason is just because you might use this in your IA. One of the best IAs I read last year was James's IA on modeling tumor cells using function models. And he talks about different kinds of models, and also he varies all these unknown constants. So A and B here are unknown constants. He varies these constants and looks at the function and its behavior, and he made an entire IA out of that. And so it's an important concept, but also I feel like it's the one thing that it always comes up in some form in your exams. Like it'll show up in some form. I can almost guarantee it. In fact, last year there were some students who were not able to answer entire section B questions simply because they couldn't kind of wrap their head around unknown constants and what role they play and how to reason about them and reason precisely about them. So I encourage you to, just walk or stay with me as we do this question. It is kind of a difficult one, but I think it's worth doing.